Hello everyone, this is Sandeep here from Physics HQ. In this video, we will explain how to use logbooks for solving sums of physics and chemistry subjects, which will be useful for students of 11th and 12th standard of all boards CBSE, ICSE and HSC. So let us go ahead. The contents to be covered over here is, first of all, we'll be talking about log and antilog. This is how a log table looks like. Then we have antilog table. Then we'll be covering sine, cos and tan table. So this is how a sine table looks like. So for a particular given degree, we can calculate sine of that degree. So let us say theta is 15, so we can calculate sine 15 from here. Okay, now mind you, in the logbook there is two sine ka table. One is natural sine and another one is logarithmic sine. Make sure to use natural sines for our sums. Similarly, we will have tables like natural cos and natural tan. Next, we will be covering reciprocal of a number. So a 4-digit number, if we have in denominator, we can find its reciprocal using this table very easily. Next, we'll be talking about square and square root of numbers. So this is the table for finding square. So if you want to find square of 359, so look for 35 over here and 9 in the first row. Wherever they meet, that becomes the value. So we will see this in detail later on. Similarly, we have table for square root. For square root, we got two different tables, one from 1 to 10. There is another table which is from 10 to 99. So these are the topics that we'll be covering with various examples. These things will be helpful to you all for solving the sums. So let us start with the first topic, which is log and antilog. So let us start with log and antilog with this example. Before starting with this, we need to remember three properties of log. Log of a upon b is log a minus log b. Log of a into b is log a plus log b. And lastly, log of a raised to b is b log of a. These three things we need to remember, and there is one more thing we need to take care is the numerator should be greater than denominator so that the process doesn't become complex. I will explain that with an example. So let us go ahead. So this is the number we need to take log of. We can write it as, first we'll take log of everything and then antilog of it. We got log of 2.35 plus log of 3.17 because that number is multiplied. Next, it is minus log of 3.42 because 3.42 is divided. So as per first property, divided number will be subtracted in log. Now let us try and find the log of these numbers. So first number is 2.35. So what to do is look for 23 in the first column and 5 in the first row. What we get is 3711. So that is the value over here, 3711, but this is after the decimal. So what to put before the decimal? Check the number of digits before the decimal point. There is only one digit. Whatever is the number of digit, subtract it with 1. Okay. So the formula is number of digit before decimal point minus 1. We got only one digit over here, minus 1. Likewise, for the next number, we will look for 31 and 7. We got 31 over here, 7 in the first row, and they coincide over here. So we got 5011. So the answer over here is 5011 with a decimal point before that. Again, there is only one digit before the decimal point in given number. So 1 minus 1 is 0. Lastly, 34 ka 2. We have 34 in the second last row and 2 is over here. We got 5340. 40. Again, only one digit before the decimal point and 1 minus 1 is 0. So it is 0.5340. Now when you calculate, add these two and subtract from this, you will get 0.3382. Now to calculate this, now we need to look for antilog table. This is the antilog table. We need to look for 0.33. So have a look in the first column. This is where 0.33 is. Next is 8. So in the first row, you can find 8 over here. And these row and column coincide over here. What we get is 2178. Along with that, we got one more digit over here, 2. So for that, you need to go into this mean difference wala column and within that mean difference we have this entry 2 over here. So from column number 2 what we get is we get 1. So we will just add it to this number. So 2178 plus 1 is 2179. Now here where to put the decimal point, for which you need to look at this number. What is the value of this? 0. Whatever is the value plus 1. Okay? So the simple rule is value plus 1. Value of what? Digit before the decimal. Okay, so before the decimal point the digit over here is 0. Uska value plus 1. So it is 0 plus 1, which gives us 1. So we will place the decimal point after one digit. So we got the answer as 2.179. I hope you all understood this. Let us try one more example over here. Now in this example you will find that there is one number with a power 2. Okay, we will write this in the form of antilog log of 7.82, and this power will come before the log. So it is 2 log of 7.82. This is from this third property that we saw. Plus log of 6.42, because it is multiplied it will be added, and 6.282 is divided, therefore write it with a minus sign. Now let us try and solve this from the log table. So first number is 7.82. So we will look for 78 ka 2. 78 ka 2 comes over here. What value we have? 8932. We got 8932. Again, how many digits are there in this number before the decimal point? Only 1. So 1 minus 1 is 0. We'll multiply this with 2. And then we got next number as 6.42. So we will look for 64 ka 2, which is 8075. Got 8075 again with 0 with the same logic, minus over here we'll look for 62, then 8. 62 ka 8 will bring us over here in 7980. Last digit is 2. So for this we'll go to this mean difference wala column. That second entry is 1, and we need to add this. So over here what we get is 7980 plus 1 is 7981. Again we will have 0.79 again, because we got only one digit before the decimal point and 1 minus 1 is 0. Now after you calculate these things you will get something around 1.7959. Okay, so we need to look for the antilog for this. What we need to find over here is 0.79. 0.79 is the second last. 0.79 ka 5 we got 6237. Plus we need to add the mean difference from 9th column. So this is mean difference and this is the 9th column, and 9th column is giving us value 13. So we will add this value to what we got over here. So we have 6237 plus 13, which will be 6250. 6237 plus 13 is 6250. Now again, where to put the decimal point? So remember this formula. Whatever is the value of the digit before decimal point, what is the value? It is 1. Plus 1 will make it 2. So we will place decimal point after 2 digits. So we got the answer as 62.5. Okay. Now let us take one more example like this. Now in this example, important point to note over here is when you try and find out the approximate value over here in the numerator, it is less than the denominator. So your fraction will be less than 1, and because of which the log ka answer will become negative. And you cannot take antilog of a negative number, and then the process complicates and you need to go through a couple of more steps. To avoid all that, just make sure that your numerator is greater than the denominator. So what we can do is we can write 44.6 into 3.142 into 10 raised to minus 1 and divided by 18.87. So what we'll do is we will account this 10 raised to minus 1 afterwards. So this can be written as antilog log of 44.6 plus log of 3.142 minus log of 18.87. Now this I'll leave it to y'all to check from the table. Log of 44.6 will be 1.6493. Now when you look it from the table, you will get 6493. The reason we have written 1 over here is because we got 2 digits before the decimal point, and the number of digits is 2 minus 1, it is 1. So that is why we got 1.6493 over here, plus 0.4972 minus, again you got 18 two digits, so it will be 2.1465. Now when you will simplify this, you will get this as 0.8707, and antilog of this comes out to be 7425. Now what is the value before the decimal point? 0. Okay, and what we have written is we will add 1 to the value. So 0 plus 1 is 1. So decimal point will be placed after 1 digit. So this is the answer that we get. Hope you all understood log and anti-log. Let us go ahead to the next topic. Over here we will try to understand how to find sine, cos and tan of a particular angle, and also if we are given a particular value, how to find inverse of sine, cos and tan. Let us start with simple example. This is the table for sine. Always remember that the table that we will use for solving the sum will be natural wala table. There is one more table in logbook. That table is logarithmic sine. Don't use that, use natural sines table only. Remember this part. So for the first example, we have sine of 15 degree. This is degrees in the first column, and row may it is part after the decimal point. So we don't have decimal point right now. It is just 15 degrees. So we'll look for 15 degree over here. So we got 15 over here, and there is nothing after the decimal point. So this is our answer, which is 0.2588. Next what we have is 25 degree, and there is some decimal part as well. So 25 is the last entry over here, last column, and 0.5 is somewhere over here. Okay, so what is the value coinciding with it? 4305. So we will get the answer as 0.4305. Let us see the next example. Sine of 4.64. Sine of 4 is this, 0.6 is here. We got this value, which is 0.802, but we have this additional 0.04 over here. And if you see, the mean differences are not written in degree, they are written in minutes. So what we'll do is we will convert this extra 0.04 degree into minutes. How to do that? Just multiply it by 60. Okay, so 6 4s is 24, so you will get answer as 2.4. Now this is minutes. Okay, over here also you all can see 0.1 degrees converted into 6 minutes because it is multiplied by 60. Likewise, 0.2 into 60 will give you 12 minutes. 0.3 into 60 will give you 18 minutes. So we got 2.4, but what we have in mean difference table is 2 and 3. So what we'll do is we will take some in between value. So what values we are getting over here is, the number is 2.4, and we have two options over here to go with 7 and 9. So we'll go with 7 over here because it is 2.4, right? Less than 2.5. So what we get is 0.802 plus 7. This will be 0.0809. So the answer that we get is 0.0809. So in these kind of sum where you have decimal points, let us say you got 0.06 multiplied by 60, you will get 3.6 minutes. And you can check, you can take a value, approximate value from this mean difference table, somewhere in between 3 minutes and 4 minutes. Now let us go ahead and try and sum, which is inverse of it. Means you are given the value of some angle theta, and you are supposed to find value of that theta. Okay, so over here we are given 3428. So what we'll do is, this value is somewhere in between, so we need to trace that. So have a look over here. What is this value? It is 3420, very near to this. We need that extra 8 number. So what we'll do is we'll go into this mean difference table and look for it. So we got 8 also. When we add these two, we will get our number. So what is this degree over here? 20. So we got 20 degree. And how many minutes from here? So this is 3 minutes. Okay, so we can write this as 20 degree and 3 minutes. If you want to convert this into degree, what you need to do is just divide this 3 minutes by 60. You will get answer in degrees. So this will be 1 by 20, which will be 0.05. degree. So the answer can be written as 20.05 degree. So remember this rule. For going from degree to minutes, what you need to do is you need to multiply by 60. For going from minute to degree, you need to divide by 6. Okay, have a look at the next example. 0.2345. Let us try to find out. So 0.23. So this is the nearest number I got, 0.2334. To make it 45, we need extra 11 numbers. So we got 11 over here. Yes. So what is the degree over here? So this is 13 degree. This is 30 minutes, and 30 and 4, 34 minutes. So what we got is, we got 13 degree and 30 plus 4, 34 minutes. So this is the 30 minutes that we got. We got 4 minutes over here. So it is 34, right? Next, 0.4321. Now let us try and find out 0.4321. Okay, fortunately we got it directly over here in the last row. So what is the degree over here? 25. So we got 25 degree. What is the column? Column is 36 minutes. So you got 36 minutes, or you also have degree converted over here. So you can write it as 20.6 degree. So these are the ways you can find the angles, and if angles are given, you can find their sine, and respectively you can find cosine and tangent also. There is similar table for natural cos and natural tan also. I hope you all understood this. Let us go ahead with the next topic. Let us try and understand how to find reciprocal of a 4-digit number over here. And there is one more thing that we should always remember while finding this, that the decimal point should always be placed after the first digit. Okay, if it is not placed, we can adjust it with the power of 10. So let us start with this example. What we have is, we have 1.2 first of all. So we'll look for 1.2 over here. Then 3 in the first row. What we have is 8130. The last digit is 4. So we'll look for mean difference. So mean difference may fourth column is giving us value 26. Now there is this important thing over here that I am highlighting, which is that mean difference is subtracted over here. Up till now we have added all the mean differences, but over here it will be subtracted. So what we have is, we got 8130 minus 26 will give us 0.8104. The answer is 0.8104. I hope you all got it. Let us go ahead. Next example. Now we got 12.34 over here. If you see, we don't have a number as 12 over here. So what we can do is, we can write this as 1.4 raised to 1, which is nothing but 10 raised to minus 1 divided by 1.234. Now we already calculated what is the inverse of 1.234. We can put it directly over here. What we get is 0.8104 into 10 raised to minus 1, which can be simplified as 0.08104. Okay, let us go ahead with the next example. Similarly, if you have one more decimal shifted, so instead of writing 1.234 10 raised to minus 1, over here we have shifted 2 digits, so it will be 10 raised to 2. So every time you shift towards the left, power is positive. 1 by 1.234 is 0.8104 into 10 raised to minus 2. 10 raised to 2 goes above and become 10 raised to minus 2. Similarly, let us see one more example. Over here we need to shift the decimal on the right, so therefore power will become minus 1. We know the ratio 1 by 1.234, which is 0.8104. 10 raised to minus 1 will go above and become 10 raised to 1, and answer is 8.104. Similarly, we can find the reciprocal of 2.456. So for this we will look for 2.4 first of all. So 2.4 over here. 5, let us match the rows and column. We got is 4082, and this 6 from the mean difference. So in the last row, 6th column, we got 10. So we will subtract this with 10, and what we get is 0.4072. I hope you all understood this. We need to adjust the power of 10 so that the decimal point is placed after the first digit only, right? So let us go ahead and check the next topic. Over here we'll talk about how to find square and square root from their respective tables. Let us see the first example and have a look at the table over here. So finding square of 1 2 3 is fairly simple. look for 1 2, the first two digit in the first column, then look for the second digit in first row, and wherever they coincide we will take that value as the answer over here. So what we got is, we got 15129 as the answer. Let us have a look at another example. Now this is 12.3. you don't find any decimal points in this entire table, so what we'll do is, we will write this as 123 into 10 raised to minus 1 the whole square, which can be written as 123 ka square into 10 raised to minus 2. Now 123 ka square we can find from the table, but we have already done that. So 15129 into 10 raised to minus 2 will be the answer, which can be written as 151.29. Let us check one more example. 1.23. In a similar way we can write it as 10 raised to minus 2 the whole square. That will give you 123 ka square as 15129 into 10 raised to minus 2 ka square will be 10 raised to minus 4. So we got 1.5129. Likewise you can do it for this also. So you got 123 into 10 raised to minus 3 over here. This will be 15129 into 10 raised to minus 6, which can be written as 0.015129. Okay, so this is all about squares. We can take one more example. Let us say we want to find square of 245. In that case we will look for 24 in the first column, which is the last entry over here, and 5 in the first row, and wherever they coincide we will take that value, and the answer is 60025. And if you have any decimal points, we can make adjustment as discussed with the problems with the number 1 2 3. Okay, so let us go ahead now and talk about how to find the square roots from the table. So have a look. This number is 12.3, and as mentioned at the start, there are two square roots ka table. One is from 1 to 10 and another one is from 10 to 100. So we need to find square root of 12.3. So we will be looking in this table. For 12.3, let us find 12 in the first column, the third entry, and 3 in the first row. So wherever they coincide will be our answer. So what we have is, we got 3.507. Okay, so this is our answer. Now let us go ahead with the next example. Now this example is having decimal at the after first digit, and the value is between 1 and 10. So we'll refer the other table, which is square roots for number 1 to 10. Over here we will be referring for 1.2 ka 3 because the number is 1.23. So we got the answer as 1.109. I hope you all got this. Let us take one more example. Now in this case what you have is 0.123. Okay, now you might think that I can write it as under the root of 1.23 into 10 raised to minus 1 and take the root of 1.23. That is one approach because you have that answer, but the problem is you will be stuck with root of 10 raised to minus 1, right? So what we should do always is, we should shift this in the power of 2. Okay, so instead of writing it like this, we will be writing it as 12.3 into 10 raised to minus 2. Okay, now we also have value of root of 12.3, which is 3.507, and root of 10 raised to minus 2 is 10 raised to minus 1. So this becomes fairly simple for us. Let us have a look at one more example. Now you want to find this root of 123, but we have table only from 1 to 10 and 10 to 100, so this is out of bound. Okay, so what we can do is, we can reduce the value and we will be shifting by power of 10 raised to 2. Okay, now we already know root of 1.23 from here, which is 1.109, and root of 10 square is 10. So the answer is 11.09. Let us say we want to find root of 2.687. So over here what we'll do is, we will look for 2.6 in the first column, 8 in the first row. Now wherever they'll coincide, we will take that answer. The answer is 1.637. But wait, there is one more digit, which is number 7. So we'll go to mean differences. We will look for the first row with number 7. We'll come to the same row, and this is having value 2. So we'll just add this, and what we get is 1637 plus 2 is 9. So you got the square root of 2.687 as 1.639. So you can see that how difficult values ka root and square can be found out easily by using this method. That's it from this video. I hope it was useful to you all. If you found this video useful, don't forget to share it with your friends and classmates. This is Sandeep here from Physics HQ signing off.